All right, so for example 10, this is a case where you really want to read the problem very carefully. A department store charges 1.25% per month on the unpaid balance for customers with a charge account. If a customer charges $200 and does not pay her bill for 6 months, what is her bill at that time? Now, the important thing to read here is this 1.25%. That is not the annual interest rate, is it? It's the rate per month, right? So we need to think a little bit about outside the box. This is how much the balance is increasing per month, right? So if P is our principal, okay, after T months, well, we can see that after 1 month, it would be P times 1.0125. Okay, that would be after 1 month, right? That would be okay, and actually P would be P in this case would be 200. But after T month, then after 2 months, we take this number and again multiply by 1.0125 and so on. Okay, so the formula for this unique case is our balance. This is our balance after T months. Okay. All right, so this then in that case we have again P is 200 in this case. All right, so P is 200 and T is 6. Okay, and so this is 1.0125 raised to the 6th power, and this turns out to be 215.48. That would be the balance after 6 months. Okay, what's going on here? This is kind of like we're compounding, yes, we are compounding monthly, but the annual interest rate is actually going to be 12 times this. Okay, but rather than that, that's what this boils down to. So this is a formula where you're just when you increasing something by the same percentage each month, you're being modeled like this. Last one is the zero coupon bond. Okay, a bond is something you buy. You buy now, and then you're at a certain price, and then you're guaranteed a certain amount after a certain number of years. In this case, a zero coupon bond can be redeemed in 20 years for $10,000. How much would you be willing to pay for it if you want a return of 5% compounded monthly and then 5% compounded continuously? Okay. All right. The important thing is how much are you willing to pay? Well, that's the principal. So they're asking what is P. In this case, you want A, that is the amount after the 20 years, to be 10,000, and you want, in this case, T is 20, and it's compounded monthly, so N is 12, and R is 0.05. Okay. So our equation would be 10,000 equals P times 1 plus 0.05 over 12 raised to the 12 times 20. Okay. And before we go on into this, let's see how would we do this if everything else is the same, but we're compounding continuously. On that case, we want 10,000 to be equal to P times E to the 0.05 times 20. Okay. All right. So P is going to be 10,000 divided by whatever this number is. Okay. And in this case, P will be 10,000 divided by whatever this number is. Okay. And I'll just tell you, you can figure this out on your calculator that when you're compounding monthly, you want P to be 3,686.45, and when you're compounding continuously, you want P to be 3678.45.